Okay, so we've got this equation. This one is a level 2 problem. So what my job is going to be is to figure out what x is. And this is a quadratic, so most likely we're going to have two answers. Sometimes they're unique, sometimes they're not. So when I look at this, the first step that I want to make sure that I try, step number 1, is going to be to make sure that my equation is equal to 0. Well, good news, this one is already equal to 0, so I don't have to do anything additional. Okay. Next, I have to do some of my factoring. And the first type of factoring I'm going to make sure I check for is a GCF. And the second factoring I'm going to do is my rectangle, my trinomial box factoring. Okay, so when I look at each of these terms, what I notice is there's no x in each of them, and there's no number in each of them that I can take out. So there's no GCF. It's not bad that we can't do that, it just means I don't have to do that. So then what I'm going to do is I'm going to do my factor box. So what I'm going to notice is that I have got my, this x squared term, whatever the term is there, is always going to go in my upper left-hand corner. This number at the end, my 18, is always going to go in this lower right-hand corner. Once I have this set up, what I have is I have a diagonal. And that diagonal tells me what both of my diagonals are going to multiply to. And that's 18x squared. So I know that whatever combo I get for this one has to multiply to 18x squared. The other thing I know is that it has to add to the number that's in the middle there. So not only does my diagonal have to multiply to 18x squared, the other thing it has to do is it has to add to 9x. Okay, so I'm going to use this as kind of a little check-in over here as to what to do. So I'm going to start listing things that multiply to 18x squared. And so I know 1x and 18x multiply to 18x squared. I know negative 1x and negative 18x multiply. Be careful that you don't forget that. I know 2x and 9x, and I know negative 2x and negative 9x. And I know 6x and 3x, and I know negative 6x and negative 3x. Once you find the pattern that works, don't feel like you have to keep going. And I actually found it. The one that not only multiplies, but also adds to 9x is going to be 6x and 3x. So then once I have that, I get to put those in whatever place feels like it makes the most sense to me. And so I'm just going to put 6x here and 3x here. Then what I have to do is I have to do my kind of level by level GCF. So I look at this row and I think, what can I take? What are things that multiply to give me x squared? Well, x and x. Great. If I then take an x out of this, what would I need for this measurement to get the area of 3x? Well, I would need positive 3. Do the same thing here. If I took an x out of 6x, what would I have left? I would have 6. And this final box is kind of your check, because if this times this doesn't multiply to give me 18, I've done something wrong. But guess what? I haven't in this case. It does work. Okay, so I've got my problem all factored. So then I'm going to write the equivalent expression. So instead of writing x squared plus 9x plus 18, what I end up getting is x plus 3, the dimension up there, and then x plus 6, the dimension right there. All that's equivalent to this expression, and it equals 0. My fourth and final step becomes I have to set each parenthesis equal to 0 and solve, okay? Ultimately, I'm trying to get what x equals, so I'm going to figure out what x equals for each of these parentheses. If one of these parentheses equals 0, then I know that my whole equation equals 0. It also tells me where this graph crosses the x-axis, or when y equals 0, which is another way to think of the answer. So then I end up having x plus 3 equals 0, minus 3, x equals negative 3. Done. That works. X plus 6 equals 0, minus 6, x equals negative 6. Done. It works. I've got my two answers. I've solved my equation because now I know what x equals.